So Ivar is this Serbian kind of saucy thing. It's a bunch of like wood roasted tomatoes and bell peppers and all of that, and then kind of blended up into a salsa-like kind of consistency. So I do the best I can living in foreign countries to make some foods that are familiar back home. But diving in without ado, I'm going to be talking today about JavaScript performance in extreme environments. I got started doing this work about a year and a half ago in the Refugee Aid Movement over here in Europe. And yeah, like you said, it's very applicable to other crisis response around the world. Glad to be here today. I was really looking forward to Perf Matters, and I wouldn't miss it for the world. So disqualifications, and wow, that screen is really bright. I'm not an expert. I'm actually just a pretty average web developer, which is good because everything I talk about here is something that is a standard technique you can bring back to the day job on Thursday and should definitely feel comfortable to try it out in your own projects. I loved Ira's point to mention where we're calling in from. So solidarity from Serbia and lockdown over here. That's me. I didn't know if we'd have video or not. So this was on one of the trips I took. I think I was in Italy meeting with aid groups in Rome in this photo. And this is Shorba. Shorba is our lovely street dog mascot here in Serbia. There's a great street dog culture. They're super friendly and well adjusted, and we love Shorba a lot. But this is also the point where I bring up a small content warning. We will be talking about some difficult topics today, including of course, like the environments that asylum seekers live in and that aid workers work in. I will show photos to provide context, but not show photos of any people, just of the environments. So I want to make sure I know that we're all probably like a little bit emotional with everything going on in the world. It's totally okay if you want to just mute me or turn your screen off or go to lunch early. Like, no problem. Totally understand that. So diving in here. I guess just like a quick overview, I'll go through some background and context for the aid movement, and then we'll take a look at the extreme environments together. We'll set some performance goals and look at tips and techniques to improve performance. And then I want to wrap up with like really why performance matters on a human level. So the Refugee Aid Movement, it's the largest grassroots movement in the world, although it might be quickly becoming eclipsed by the current medical aid movement and the environmentalism movement. But just to give you some context, there have been tens of thousands of volunteers that have joined hundreds of refugee aid groups in dozens of countries over the past 4 years to welcome over 1 million newcomers to Europe. The way it's structured is a series of autonomous distributed aid groups. And it's kind of this spoken hub model where in each country or large city, you'll have a couple of main groups that are very well connected, like a central warehouse. And then they'll work with a lot of local groups focusing on specific individual projects. So this is really great. These groups are super resilient and adaptable. They can shift very rapidly as the needs change and current events unfold. And if one group happens to, it doesn't work out, they can't get funding or something, there are other groups that can step in and fill the gaps. For the most part, that's what we're doing, is that a lot of our work should be handled by the larger institutions in our world, but they have failed to do their jobs properly. And so it's up to us, right? Cool. So there are tons of different types of projects. You have everything from kind of core services such as housing and water and food distribution, as well as non-food items and hygiene, clothing. You have education. You have technology. There's like everything that you need to run a society in basic life. There's some sort of equivalent in the aid movement that is providing those services or access to resources to newcomers. Cool. So our focus is on harm reduction. Like we don't have the capacity to say like stop the war in Syria, but we can make sure that the dignity of people that are fleeing for their lives is being upheld, and that the asylum process is being followed as much as we can. We really take this idea of solidarity, not charity, to heart. The goal is not to just do something nice for someone else because it feels good, but to realize that by creating a better world for others, we also create a better world for ourselves. One of the things that I absolutely love about the aid movement, especially coming from a tech background, is that it's super diverse and it's led by women. So on the photo there, on the left, you have Rudina. She's on our board and runs an aid organization herself that puts educational contents on laptops and gets those into the informal schools in Lebanese refugee camps. On the right, you have Stephanie, who is a high-level administrator at Movement on the ground, doing field work out on the Greek islands. And in the center, you have Sarah, who is our very own director of Distribute Aid. I think it's really important to realize that this is not an issue that is going to be solvable in the sense that it won't be an issue anymore. This whole thing kind of got kicked off in 2015, early 2016 in Europe. This will be something that we need to um, support and deal with for the rest of our lives. Right now there are 70 million displaced people in the world, and 20 million of them are refugees who are fleeing to another country. If we don't get a handle on climate change, the UN estimates 250 million to a billion climate refugees by 2050. So now is the time to build the connections and infrastructure and organizing patterns so that we can have a real humanitarian response going forward. I just want to take a minute to shout out Greta Thunberg and indigenous leaders all over the world who are on the forefront of the environmental movement, because we're working on the tail end of that with displaced people, and they're really working to help the world and at the larger picture on the environmental side. So, what is Distribute Aid? We're building technological infrastructure. We're an online platform for grassroots aid groups, and our goal is really not to centralize power or control or make decisions for people. We try not to have an ego about it. We're just trying to surface structured information. So if you remember that spoken hub model where you have these central larger groups and then lots of small different aid groups, that's great. It's super resilient, but some of that comes at the cost of efficiency, where not everyone can talk to everyone else at the same time. And that results in missed opportunities. And when the margins are so small with these like tiny budgets that grassroots aid groups have, we need to really make it as efficient as possible. And so getting structured info onto an online platform where we can then do some matchmaking, make suggestions, not decisions, is a great way to improve that efficiency. Our technology is designed to empower groups instead of making decisions for them. We are working with refugee aid groups in Europe right now, and as you'll find out at the end of the talk, we are planning to do global crisis response later, but we're also doing that right now. So Distribute Aid, all our code is free as in freedom. We have the AGPL license so that hopefully everyone who uses it and builds off of it shares that back. It's also free as in beer. I couldn't imagine, charging even 20 bucks a month from an aid group that has such a small budget, because that money they really need to provide their core services. We have an all volunteer remote first team. I have calls with folks in Norway, in Brazil, in Thailand, and people are just putting in time on nights and weekends to help us move along. And there's too many people who've contributed to this project to thank individually, but to the Distribute Aid team, I love y'all. So our supply chain tools, I guess we have we're mostly focused on the supply chain right now with what are the needs, who has what resources available, can we match them, and then can we figure out the international shipping. They were in beta and we were slowly building them and testing them, but now very rapidly are going global. Again, more on that later. And I'm very proud, in our first year of operation last year, we shipped over $1 million worth of aid internationally. Cool. So this is what it looks like. As you can see, not super advanced on the front end, but we got the basics down. We have group profiles. This is our first iteration on the kind of inventory management and needs and available item matching. We have shipments. So this is where groups can plan, what's the route? How can we get other people to contribute to fill up a full truck, which is much more efficient than sending individual boxes through the post or something like that. And this is what a shipment looks like. So that's a truck with 180,000 bars of soap. We also included some winter aid. We had about 5 different aid groups contribute to this on the supply side. And then that truck gets sent to Greece. Like in February, we sent the shipment, and it goes to a big central warehouse where it's kind of sorted and processed and split up. And then it gets delivered to groups all over Greece or whatever country we're sending it, who can get it into the hands of the people who need it most. And I think all in all, we were able to get the soap and split it up to 19 different aid groups in 4 different locations in Greece. So it's like pretty complex, and you can imagine that without some sort of extra support, each one of these individual groups wouldn't be able to coordinate, in such a large and complex shipment. Cool. So extreme environments, what they are, and what do we need to be thinking about for performance? And this is where we'll start to show some photos. So maybe not that extreme. You can make the call. um, this is the Moria refugee camp on the Greek island of Lesbos. It was originally a prison with a capacity for 3,500 people. And you can see kind of the old prison infrastructure in the background of that photo. Last year, it had 10,000 residents living there. And that's why you have all of these tents in the surrounding olive groves, kind of overflow areas of the camp. And in January, this is what it looks like. There are now 20,000 people that call the Moria refugee camp home. Obviously, this is not a good situation. And we've been kind of dealing with this crisis of the breakdown of the European asylum infrastructure, I guess over the past 12 to 6 months already, and now have a bunch of other considerations. That's the photo of the outside of the camp. It's obviously not a very friendly or welcoming environment for newcomers to Europe. And this is what it looks like inside on the ground. So this is where we start to talk about performance. As you can imagine, there's not regular access to power. There's bad cell signal in these remote environments. Basically, if you run out of data or if you run out of power, then it doesn't matter how optimized our tools are because you simply can't use them. And aid workers are running around trying to help folks for 10 to 12 hours a day. Every day I would know because I spent a few weeks one summer building tents out there. So we have to get the performance right and make sure that people are connected and we're not draining their batteries and things like that, so that our tools are actually useful. Cool. There's also lots of other tech projects that work in similarly extreme environments. There's lots of great tech supporting search and rescue operations at sea. We also know of other groups working on, border violence monitoring and things like that. And this is a photo kind of closer to me. This is the Serbian-Hungarian border right there. And these border violence monitoring groups are kind of recording stories and documenting illegal pushbacks and other things that happen. This is the US-Mexico border, so bringing it closer to home for folks in the States. It just seems like authoritarian regimes around the world really love barbed wire. It's kind of a staple for them. So we also get to work in some like really cool places. This is the old Pampariki warehouse, which it's actually the 2003 Greek Olympic basketball stadium, and it was just kind of sitting empty. And they asked the government if they could use it to set up a central warehouse for aid groups in Athens. And so I got to go there and talk to our users in person and check it out, which was a lot of fun. So just roaming around this place place for a day. That's what it looks like on the inside. Aid groups are really scrappy and resourceful, and they said, hey, we have access to this empty building. We can just set up our whole warehouse in the concession ring area and divide up the boxes, and sort items using that space. But as you can imagine, even in this environment, they might have access to power, but if you have to leave your phone plugged in to charge it up because our app drains the battery, you're going to be walking all over. You're going to be far away. You're not going to come back for a few hours. And then, like, what's the point, right? They do have cell signal there. But again, this is on the outskirts of town, so it's not great. And there's no Wi Fi in the building. Cool. So when looking at these extreme environments, we need to keep like certain aspects of performance in mind. Speed is one of them. You have high speed, which I would say is most folks connected right now in the States. You have low speed, which is me right now. I am tethering from my phone from Serbia because my apartment building shares a single Wi-Fi router for 4 different apartments. And since everyone is home from curfew, they're all on Netflix and YouTube and stuff, so I can't use my home Wi-Fi. And I'm glad that my cell data is fast enough to let me connect. You also have no speed. If there's no connection, like that's just a fact of life. And there's this special kind of situation, which I call maybe speed, which is really interesting. Maybe speed is like, let's say like you're in a camp or a warehouse, you might have some connection or some Wi-Fi, but it's not great, right? It cuts in and out, you go into dead zones and things like that. And what you see there is you see huge latency spikes where things will be running fine, and then all of a sudden it's just like loading, loading, loading. You also see a lot of like really frequent kind of on and offline transitions. So even if you have great offline support, your users might be getting whiplashed between like, hey, you're good to go, a bunch of new notifications. Oh, you're offline. Hey, you're good to go. So you need to build in some way of checking for that and making sure that you're not just like pinging your users back and forth between different on and offline states in your application. And of course, with maybe speed, race conditions really stand out, where some files will make it through and others won't. And if there's the possibility for a race condition in your code, it will happen. Yeah, and we're looking specifically here at latency, bandwidth, and throughput. So latency is that round trip time to the server and back. Bandwidth is the size of the pipe, like how much capacity your connection has. And then throughput is how much you can actually send down the line. And so we have really high latency, we have low bandwidth, and because of those two, we have low throughput. Just on a technical note, like I said, I'm a pretty average web developer, and there's some really smart people on the call. So if I get anything a little bit off, you should correct me in the Slack and listen to the smart folks. Yeah, cool. This is an example. It's another warehouse, and to show you like some of the issues with speed and this connection, that's the admin office highlighted in the back there. So they do have Wi-Fi there, and there is cell signal, but not all of the carriers are great. And the further you get away from that admin office, the weaker the Wi-Fi gets. Especially when you're walking through those stacks of boxes, there are tons of dead zones. So you can imagine like with this maybe speed, you're connected to the Wi-Fi or you have some cell signal, and then you're trying to get a count of how many boxes of men's small t-shirts you have, and you're in a dead zone and suddenly you're off. And then you step to the left and you're not in the dead zone and you're suddenly on again. Can cause a lot of problems. In general, these warehouses are, you can see the giant metal structure. Think really large Faraday cage to a certain respect. So this is another great example. You remember that camp that I showed you photos of a little bit ago? That is in the upper left. That is the Moria camp. On the bottom right of this photo is the Greek town of Mytilene. And the way that they get access to Wi-Fi in that camp is they have something plugged in Mytilene. They actually beam it to a water tower in the middle with a satellite dish, bounce it off of that to a receiving satellite dish in the administrative administrative office in the camp, and then they distribute it through the camp through a series of Wi-Fi repeaters. So I helped set one of those up on the telephone poles, and there are two channels. There's the kind of the aid workers channel, so that they can do Zoom calls and talk to the folks that they need to, but they also provide a connection for folks in camp. You know, boredom is a real problem. People want to connect with their friends and family back home. And so you have a lot of folks who are all trying to access this very tiny connection with very limited bandwidth. We should also definitely talk about resources. So like I said, like here right now, I'm on metered mobile data. You have unmetered, which would be Wi-Fi at a coffee shop or at work. And like sometimes you just don't have data at all. Same thing with power. So you can be plugged in, good to go. You could be limited if you're walking around and don't have time to charge anything, or your phone could just be dead. Your laptop could be dead. There's no power there. And the last thing to consider is devices. So we're looking at mostly in the aid movement, people have laptops and phones, not tons of tablets. They use pretty standard operating systems and browsers, but they use old donated equipment. So my friend was very kind to give me a photo to show. She does not have a battery in her laptop, and she operates an educational center in Belgrade with about 25 students that come in each day. So this is a bit challenging for her. She makes it work, but she has to be connected, right? She has to have unmetered power. And if someone trips over the power cord accidentally, boom, there goes the last hour of work she was doing. Another friend who's kind of driving around doing lots of deliveries or taking volunteers to camp or whatever, that's his phone right now. I think that I could do a whole separate tech talk on how to make your app work when only half of the phone screen responds to touch input. But I just wanted to show these photos to give you a sense of like what the reality is that we deal with every day. Cool. And you might be like, hey, so like this is cool. It's interesting to learn about, but I don't really see how it applies at the day job or to my personal projects. It's actually more relevant than you might think. A slow connection is slow, whether it's a warehouse with bad signal or the basement of an office building. No connection is no connection. It doesn't matter if you're in a camp or your CEO is on a Gulfstream plane. A dead battery is a dead battery. You could spend $1,000 on an iPhone, or you could, pick one out of the donation box. But if the battery is dead, you can't use anything. And there's lots of different types of folks, like Aaron was talking about, that only have access to older hardware operating systems, and that's true for aid workers. That's true for a lot of teachers, hospitals, because they have lots of legacy systems that might need, oh gosh, I don't know, Windows XP or something. They need to still run that. So definitely keep this in mind and try to, learn from what I'm talking about today and figure out which of your users it really applies to. It might not be everything across the board, but I'm sure there are some folks that have some of these issues that are already using your app or product. Cool. So definitely start with performance goals. What are we looking at here? For this talk and for our application on the devices and speed side, we're trying to emulate a mid-range Android device with a bad 3G connection. So the bad connection we're going to say is 400 kilobytes a second of bandwidth and a 400 millisecond latency on that round trip request response time. The mid-range Android device, we can use a 6 times slowdown in the Chrome web dev tools to kind of simulate that. We really want to minimize data and power use. And we're going to be looking at 2 specific metrics. I'm sure there are a lot more, but we're going to look at 2 today. The time to first meaningful paint for the initial load of the application and then subsequent loads, and the time to interactivity, again, on the initial and subsequent loads. So we've set our performance goals. Now let's look at our product goals. We want to be able to do useful things, like regardless of the circumstance or what resources or power or Wi-Fi people have access to. We want something that's useful. Even if it's not everything, they can still do something. We've made the decision that we're only going to support modern browsers. So we will support Edge, but we're not going to support Internet Explorer. I think that on my end personally, if someone can only use Internet Explorer, I need to go find them a laptop. I have lots of friends in tech, and if their computer is that old or they can't upgrade because of a licensing fee or something, then the solution is not to spend a lot of time hacking stuff for IE. It's to get them access to the resources they need. And then we really want it to work offline. But again, we don't have tons of like, I don't have $1 million budget to hire developers who can build out a fully offline app or anything. It's okay to cut functionality. The maps page, hey, we're loading that from OpenStreetMaps right now. And if you're not connected, like maybe we just need to load a photo, or maybe there's no maps, and that's okay. Cut content. Maybe we don't need all of the images. Or we can't cache everything. So, you might get to a page, it's like, hey, check this again when you're offline, but at least it lets you know. And then keeping the user informed. User consent to things like downloading data and setting up this offline functionality is super important. And I'll talk a bit more about that in a minute. Business goals. On the internal side, I don't like ultimatums. It shouldn't be like it has to work offline before we can launch or something. Let's just take a look at where things are at and how we can improve them one step at a time and continue to iterate. Performance is not a, like check it once and then you release and you're good to go. I think that performance is a constantly evolving conversation on your dev teams because the world is constantly changing. You might be getting into new markets with users that have different performance needs, or there might be new technologies coming out which, help enable access or something like that. On our ends, we need to keep the testing overhead super reasonable. There's no lab. We can't test on like a ton of different real world devices. We also are like super busy, so we don't have tons of time for performance testing. So it needs to be simple, reliable, something that any one of our technically minded volunteers can do. Keep that testing overhead low. And then I think the most important thing is just like asking users and talking to our users about how it's performing in real life. So making it easy to gather that feedback, maintaining strong relationships and connections with them, asking them to help with specific tests from time to time is a great way of just reaching out and both strengthening your business relationships with them, but also making sure that your kind of performance testing lines up with the real world and the feedback you're getting. I think the last goal is we really need to make sure that this works for people, these human goals. So regardless of the environment and how extreme that is, does your stuff work? Does it load at all? And then related to this, I view accessibility and internationalization and affordability. Those are all like really big areas, but I think that anyone who's focused on performance really needs to consider those as part of that performance work. And again, like I'm not an expert on all of these areas and I might mess up from time to time myself, but that should be an active part of the conversation you're having with your front end developers, with all your developers, and especially as part of the larger performance conversation. Cool. So let's dive into some strategies and tools and techniques. And this is where we get into the really fun technical stuff. I'm going to go through a lot of the standard techniques kind of quickly. The goal is to kind of show you what's out there and what you can be doing, and then watch this on YouTube if you're like trying to dive in and actually implement some of this stuff. And really, again, not the expert. Go find a blog post written by someone who's much smarter than me. This is our stack, at least it was up until 9 days ago. So we were running an Elixir Phonics backend using Nginx to serve it up on a $5 DigitalOcean droplet. We used Webpack to optimize our front end assets, and our front end is super simple. It just uses some jQuery. So not a lot going on the front end, which is actually good, as you'll see. So to minimize Power, right? Just looking at my notes. Um, there's a couple of things that we can do. We really are focused on two things to reduce the drain on battery. We want to cut out as much antenna use as possible because that is a huge source of battery drain. And we want to cut out as much CPU and GPU use as possible. So like screen time and stuff, if people are looking at the screen, that's fine because they're using your application. But how can we minimize activating that antenna and sending requests back and forth? And how can we minimize, running something that's CPU or GPU intensive? Um, yeah. So there are a few strategies here. The first one is we can batch requests. Rather than sending out a whole bunch of requests every 50 milliseconds, could we batch those out and send them out once a second, perhaps? Related to that, polling is not a great technique for kind of heartbeat polling or sending telemetry and like kind of user usage data. You really want to use a service worker to kind of queue that and batch it and send it. Really, as much as possible, you want your requests to be user driven. So the user does something, and then that's a great time to send that request along with a number of other ones. Yep. WebSockets are pretty good actually. If you can get a WebSocket going, they'll idle. I was worried that they would keep the antenna active the whole time, but they'll actually idle and slow the antenna down or like shut it down. And then when you send the next request, they'll activate the antenna again. You still need to batch those requests, but at least you can confidently use WebSockets without continually running the phone antenna. And HTTP2 is good because there's less connections that are open. I was wondering if that would work well, and it looks like it does. On the animation and kind of timers and event timeouts, you really want to minimize animation. Again, if it's not requested by the user, don't have a giant loader spinning. You can just say loading, right? Don't be playing a giant GIF in the background unless the user's like actually scrolling to that page, or wants to see that. Timers can be synced up. So if you have like one timer that hits every, I don't know, 100 milliseconds and one that hits every 250 milliseconds, how can you adjust those timings or kind of combine the timers and have them go in sync so that you're not spinning up the CPU at a whole bunch of different times? Again, it's this whole idea of batching. And use event timeouts. Like if you have a scroll event, any of the standard stuff there is going to be helpful so that you don't have tons of events hitting the CPU and triggering a lot of processing when maybe you don't need all of the results of those events. You just need to update it once in a while. Cool. And so this is Google. When you type in a character into Google search, it sends a request every single time. So like obviously this is really hitting that antenna hard on your phone. It would be much better to just let the user type out what they want and then press the send button and make a single request. It's nice that Google like has that kind of real-time results as you're typing, but in these extreme environments, it actually makes it much less usable. This is a site that had a bunch of spinners on it, and you can just see how hard that's hammering the CPU and the GPU there. It's just like every time that there's an animation going, it's doing a lot of work. Now, I'm not an expert on kind of the animation or graphical sides of things, and there might be more techniques here that you can use to improve this performance. But in my view, it's just easier to not have this issue by not dealing with it, right? Again, don't show a loading spinner. You can just show loading if your stuff needs to work in these environments. We have another strategy here. We want to minimize data use. So we want to compress payloads as much as possible. We want to only load content as needed if it's requested by the user. We want to cache anything we can very aggressively. And for pre-caching, it's really important to get consent, right? So like if you're going to do something like I want to, look at all of the links a user could click on the page and then take the top 10 of those that they're most likely to click on and pre-cache that next load, that's great. But if people are on tight budgets and are paying, for data as you go, you want to let them know that you're going to do that and get them to say, yes, this is useful, or no, like I'd much rather not potentially waste the data or waste the money. Yeah. Cool. So I think that was it. And then the last one is speed. Again, same technique as reducing data. If you compress the payloads, if you cache aggressively, that'll make everything a lot faster. So it's nice. You get kind of two wins on two different angles on the performance side, just by using the same technique. Server-side rendering is really important, especially when we're looking at, that time to first paint. Because that'll just dump a bunch of HTML down, even if it's just like a welcome message or a loading message. Show something on the screen, and then if you have like a single page application or something, you can kind of like load up the data in the background and fill out that application window as you go. Yep, and you want to minimize the critical path. So anything that doesn't have to run right away or load right away should be delayed as much as possible. A great example there is image loading, right? So if you can load images that are below the fold after you get the time to interactive down, and users can start using what they can already see, then that'll really speed things up. And we'll see how that works in a minute. So this is the page that we're doing our tests on. I like this as about like 30 or 40 aid groups listed on it. It has some user generated content, the names, the images, so lots of images to play with. And we're gonna try to see how quickly we can get this to load. Again, our performance goals are set up here is that we have a 400 kilobyte a second round trip time and on the latency side. And wait, I'm sorry, we have a 400 millisecond round trip time on the latency side, and there's a 400 kilobyte a second pipe that's open. So that's our throughput right there. We also have a 6 times slowdown using the Chrome Dev Tools to simulate a bad Android device. And the initial load, we already have some goodies out the box because we're using Elixir and we have a very simple front end. We get server-side rendering. We're already using Webpack for minimization and uglification. And Phonics on the server side has built-in cache busting. So it actually allows us to cache resources like our styles or our vendor scripts or whatever out of the box. Kind of good, kind of bad. So the first meaningful paint takes about 5 seconds. The time to interactive though, whew, that is not pretty. That is 20 seconds right there. And we've sent just over a megabyte of data. Just if I didn't say it earlier, our goals for the first meaningful paint, we want to get that down to 2 seconds or less on the initial load and 1 second or less on subsequent loads. And for time to interactive, we want to get that down to 5 seconds or less on the initial load and 2 seconds on subsequent loads. So we are definitely not hitting our goals as it is on the initial load. And you can see just how long a lot of that is taking right here in the networking panel. And a lot of that is just straight up loading things, which we will deal with in a minute. Subsequent loads, that's a little bit better. I think we actually have hit our goals there just about. So it's 1 second to first meaningful paint and time to interactive. We're only transferring 12 kilobytes, and then it's loading a lot of the scripts because we have that caching built in from the start. So it's loading all of that. So you can see right here, we're just getting the HTML content for the groups page to see if there's any updates, but all the style sheets, all the images and fonts and stuff are already cached. So that's a big win out of the box. Let's look at some speed improvements. How can we make this faster? We added Brotli and HTTP2 through Nginx. We added bundle splitting through Webpack, and we have a very simple strategy there for now. We have our application styles and JavaScripts, and then we have our vendors. The idea being that the vendors can be bundled up together, and those change a lot less frequently, so that'll live much longer in the cache. And then the application styles, because it's under active development, and our JavaScript code change more frequently. And so by separating the two, we can have this long-lived cache and then a much shorter-lived cache as we get improvements out the door week by week. We've also resized group logos to display dimensions. So we actually use what is it, Image Magic or something on the server. And when the user uploads a logo, we kind of cut that down to different sizes and to really make sure that we're only loading an image as large as it needs to be, instead of loading like the original format or something that's too big. We're going to add lazy loading. So if you remember that list of groups with all their logos, hey, if you have the group name there, we can load the logos in the background and those will come in over time, but that's maybe not the most important content on that page. And then the last thing was that I was loading all of the font awesome icons at once, and we've cut that down to just the icons that we're using. So that's what we're doing for speed improvements. And the results are fantastic. On the initial load, we're hitting our goals. We are under 2 seconds for the first meaningful paint. That's a 66% reduction in time. And then the time to interactive is under 5 seconds, which is a 79% improvement. We just cut out, basically, like if you don't need it, don't send it down the line, right? So we cut out a lot of data. It only had to transfer 215 kilobytes. And then it loaded 511. That's after it gets uncompressed. So the compression helped cut down 50% of the amount of data that we had to transfer there. And you can see that. You can see like on the right, that's where all of the group logos and stuff are being loaded. And on the left here, that is the initial thing. You can see the first meaningful paint on the timings there. So once we get that initial HTML response, it can load it right away from the server. We don't have to do a bunch of JavaScript to then generate the page or process the template. And then the time to interactive, I'm not sure where that is. But the point being, like, these strategies really made an impact, and you can see what that looks like here in the Chrome DevTools. Subsequent loads are great as well. We cut that down, so we're definitely hitting our goals at this point. Yeah. So the last thing that we wanted to add in at this point was a service worker. The goal is to really cache all of the static assets up front and then serve static assets with a cache first approach. Basically, if you have the vendor styles or the distributed aid logo already in the cache, it's probably fine to just serve that. And then maybe in the background, once that's on the page, you can go check and see if there's anything new. We also want to cache pages as they are visited. So as you go through the site, you hit that home page, maybe you go check out a few groups profiles. To me, that says you're interested in those groups. So let's go ahead and cache those pages. We'll serve those with a network first approach. So if you go back to the page and you're connected online, it will try to grab the latest content in case the user data has changed. But if it can't do that, if you're offline or if that times out or something, then it'll serve what's previously cached. And I think it's okay. We don't really ask for the user consent to cache stuff that's already loaded. But if we wanted to grab like a list of all of the group profiles or something like that, that's when you need a big button to like, hey, download it and make it work offline. So this again has huge improvements, except we're transferring quite a bit more information, but that's like such a small number, it doesn't really matter as much. I guess that's just like the service worker code that had to be added there. But now we've gotten our first meaningful paint down to half a second, the time to interactive down to 6/10 of a second, and we're loading. We're only transferring about 7 kilobytes, and then once that gets uncompressed, it's about half a megabyte there. So I'm really happy with this on the initial load, and you can see a lot of that happening right here where there's no network time. Like look at how little network time there is. It's able to just pull everything up from the service worker as much as possible. And once we get the service worker, if it's offline, right? So when it's online, it does try to grab, the updated user content. Like it will hit at least for the main page, and then serve up the cached images or styles. When it's offline, it's all coming from the service worker and from the browser cache, and it is blazing fast. I mean, 100 milliseconds for first meaningful paint, 150 for time to interactive, nothing transferred, and then it just loads up about half a kilobyte again from the service worker cache. So I'm really happy with this. Yep, that's Shorb again. Basically, our strategy here, we can go to aid groups now and say, hey, like grab the latest version of our application. Give your consent, download that when you're at home at the beginning of the day. Go walk around camp and help people and not worry about it. Just like hit airplane mode and do what you need to do, and then go back home, unhit airplane mode, and load that up. And that's a perfectly valid strategy for these extreme environments. Like we can ask our users to do things in certain ways if that makes the most sense for them. So this is Shorba again. This is another content warning. This is where I'm going to start talking about our recent work in response to COVID and kind of the global grassroots movement that we are playing a key part in developing. Again, totally understand if this is not your cup of tea at the moment. Now would be a great time to pause the call or mute me or something, get an early start on lunch, and I'll be wrapping it up here. I just want to make sure I'm not going too far over. So we got like a few minutes and then, yeah, cool. So performance really matters. Like it's not just a tagline. I love the name of this conference because it really makes a difference, especially once you get into these extreme environments or in situations like we're dealing with COVID, where things are happening so fast. Um, but I want to actually not talk about technical performance right now. I want to talk about organizational and societal performance. And so what we're looking at is kind of in the big picture, you have governments and like larger societies and how they work and how they're organized. Some governments have been really smart and acted really quickly in response to COVID. Other governments are still not doing enough, which is tragic. Then you have like corporate or institutional performance at the organizational level. And as we all saw in the past couple of weeks, that's been a pretty poor response, where Wall Street is the ones getting the bailouts, and they're still worried about, that bottom line instead of just how are we going to get through this. Fortunately, as you'll see, there are a number of corporations that are taking the COVID response very seriously and doing what they're trying to help. But overall, I'm like not super impressed with the corporate world or the larger institutions. What I love, of course, is the kind of grassroots and community level response. We're not able to do as much overall, but we're, again, super resilient, super adaptable, and really can reach out because we know our communities to make sure that the people who need help get it. And then finally, the individual response, which I hope everyone is doing a good job of with the social distancing and things like that, but also making sure you're not over consuming resources, right? Like hoarding is not something anyone should be doing right now. Take what you need, stock up for a few weeks, but there's no reason to be featured on MSNBC because you have 10,000 rolls of toilet paper in your house. Cool. Again, on the grassroots level, what I love about these scrappy aid groups, whether it's refugee aid groups, medical aid, or some other issue, like street outreach teams, is that they're really fast and nimble. They're very low cost and efficient. They are lower volume. Like we are working with the resources that communities can spare to help each other, but they're everywhere. And I think that's what makes up for it really, is that we can really fill those gaps and work with folks who often get lost in the nooks and crannies of society, and that is almost more important than the larger scale response, which is often too slow and too blunt. And yeah. We're able to work around red tape very well. There's a lot of very gray legal areas that my friends and I operate in. It's nothing super illegal, but it's nothing that I don't know. Like the most important thing to us is just working around that red tape and getting help to the folks who need it. And we kind of set up these Walter White style delivery networks, where it's like, okay, we need to move something into a country. We need to get medical supplies somewhere. Rather than having to deal with a whole bunch of difficulties at customs, can we just throw them in a backpack or a suitcase and have a volunteer who's flying out there anyways bring them as a carry-on, right? Let's be creative because, as we've seen with the government response, they're not taking things seriously, and we need to be. And if they won't, then we'll work around them. Cool. So just on Distribute Aid side, we were really lucky and we got 120,000 bars of soap to Greece in February, which was able to be distributed through an emergency distribution to say about 30,000 folks on the Greek islands before aid groups started losing access to the camps. In the first 2 weeks of this month, we got 50 plus pages of knowledge and info sharing resources up in 2 weeks, and we're starting to get those translated in 10 languages. And oh my goodness, someone forked my code base, which is terrifying, absolutely terrifying. We're working with Masks for Docs, which is a really big, they're probably like the US grassroots response to COVID, but they're really good about focusing beyond the US and making sure that they're sharing resources and helping folks around the world. And they're the ones who forked our code base. So within a week, they've had over 1 million hits on their website. They have 2,000 volunteers organized. They're basically creating a new worldwide mutual aid movement, and we're very happy to help share our experience and share our code and support them doing that. And maybe I shouldn't give this talk anymore because they've thrown out my beautiful performant front end code and are replacing it with something that is more applicable to the medical aid scene. But I think because like I've spent this time doing this performance work, we can continue to work that back in, right? Performance isn't like a one-stop shop. It's something that you have to be continuous about and you have to make trade-offs for, but can improve over time. So I don't want to be too corporate-y. There's a lot of great groups that are working on this COVID response at all levels. And we also, of course, are really paying attention to the aid organizations that we love so dearly and making sure that no one is left behind, right? We need to make sure that everybody everywhere is protected from COVID because it is truly a worldwide crisis. And that's the type of performance to me that matters the most today. Cool. Join us like on the individual level, take care of yourself, check up on your neighbors, help your community, stand up what's right at work, and don't wait on governments to make a better world. You can get involved at resources.distributeaid.org, massfordocs.com, and on the refugee aid side, indigovolunteers.org. And thank you. There's our Twitter handles. I would love to connect and talk and geek out. I'm sorry for running a little bit over time. Cool.